Okay, let's have a class, and we will finish talk about this section today, and we will talk about the microbial safety of poultry processing, and on Thursday we will do a review. And next week, Tuesday, will be our exam 3 open book exam. And then afterwards, you're going to start to have a group presentation. And then if I have a time, can school in, I will talk about the vinegar manufacturing and all those topics. Okay, so we'll see. Some of you not coming here very often. I will send out the notice of the schedule. And I also want to remind everybody to prepare a presentation. If you never join a group, please to sign up next week, Tuesday, during the exam, because everybody will be here. Okay? Or you have a nearby friends, please join them and sign it. Okay, that is important. Okay, let's talk about these slides first. This is talk about surveillance and regulation in the United States about safety. First of all, CDC. These 4 names will be tested you in the exam, but since it's an open book, so it doesn't matter, you can just open book and find it. So CDC, always remember, this is Centers for Disease Control and Prevention. What they do is surveillance. What means surveillance? Which means they have a database to know the outbreak strains in their very tedious software. And then if you have outbreaks strain reported in some places, then they will to see the matching. If the bands, which are the molecular bands, match in their database, then we'll say 95% or 99% the pathogen is designated. What they do in the older time, they're using food net and the puzzle nets. And the food nets and the puzzle nets is based on the results is PFGE, which is a puzzle field geoelectrophoresis, which are the fingerprints, DNA fingerprints. They have a 3-bands rule, which means if you have an E. coli O157H7, they also have a database have an E. coli O157H7. If your PFGE bands and the database bands are completely overlapped or matched, and less than 3 bands difference, then they could be say your E. coli O157H7 is designated by their database, which means the outbreak is caused by O157H7. However, in the recent years, this has been changed a little bit. They no longer, some places, using PFGE. What they do is a whole genome sequencing. So what this means, if I get isolates from a place, I will be extracting DNA and directed to do whole genome sequence. They have another database called the WGS database. They could be based on the whole genome sequence, which means the ATGC, the TDS bands, and then they will see whether they match their database. So they no longer use PFG using whole genome sequence. Okay, so that's the CDC. Now, regarding the regulations, there is 2 different regulations, which is FDA and USDA FSIS. I believe Dr. Kenny mentioned about it. So, what is USDA FSIS? This is United States Department of Agriculture Food Safety and Inspection Service. They are responsible for poultry, meat, red meat, and processed egg. This is a tricky thing. What means a processed egg? If you have a hamburger or sandwich, you have the egg in the middle. This is processed egg. What is a raw egg? You get a box of eggs from Kruger, $1, 12 or $2 dozen with omega-3. That is called a raw egg. A raw egg is belonging to the responsibility is FDA. This is, Food Drug Administration. Their headquarters, both of these are in Washington, D.C. It's about half an hour from here, not too far away. And obviously, Food and Drug Administration, they have a drug responsibility, but the food is also. What they do is other things. Let's say fresh produce, juice, and raw egg, and imported food. And I mentioned about before, all the time we had HACCP. We still have it, but right now we had FDA comes out with FSMA, Food Safety Modernization Act, coming out with a preventive control, process control of the human foods. So there is a tendency, which is FDA going to be taking care of all the meat products in the near future from the political standpoint. So that's just want to let you know the overview of these regulations. Now, why want to introduce these things to you? I have some students previously taking my microbiology class. And one day, he is talking to me in the parking lot. He said, Dr. Sheng, I find a summer internship in USDA FSIS, and I learned in your class. So that's why I want to introduce to you. If you are interested about these microbiology jobs, FSIS, FDA, they always have those type of internships. And it's opening in the summertime. Sometimes you just go there to help him do the testing, like a pH water activity, microbiology counts. You can see all kinds of resources. They have a satellite lab, sub-labs, all kinds of places in the United States. There's a couple of them even in the West Virginia area. So this is good places if you're looking for those internships. Okay, that's why I wanted to introduce to you these regulations. And also, as a United States citizen, you should be more familiar with these regulations, these government agencies responsible for the safety. Typically, it's for the microbial safety. Okay, so that's something we want to try to conclude this part. Next part we want to talk about is microbial safety of poultry meat processing. This is a very huge topic. I do not have the slides, the PowerPoint slides cannot fit. I cannot upload, go to the eCampus, it's too large because I have lots of pictures there. So I will use PDF to do this section to talk about the material. Okay, first of all, the boar production in the United States. I just uploaded this with a new database from USDA. Old one, I always use 2014's one. This is a new one. One means boar, which means a chicken used for meat processing. You look at this table, all these red one indication, they are boar state in the United States. Obviously, the big poultry state is in the south. Number one, Georgia, Alabama, Arkansas, Texas, Mississippi, North Carolina. These couple of states, they are land-grant institutions, same as WVU. They all have a good Department of Poultry Science, such as Auburn University in Alabama, University of Georgia, Texas A&M University, University of Arkansas, Mississippi State University, and North Carolina State University. So, this tells us if in the future you are interested about poultry research, those are the universities you should look for. That's why I want to show you this. south part is always a big poultry state. And I can make a joke to you because they're hot. And also the chicken intestinal is 42 degrees Celsius. It's also hot. So it's a comfortable temperature for them to survive. Well, it's not a joke, not really, but it's just to let you to remember this. Now we can see Kentucky, I used to work there, they have 254.4 million heads per year. That's pretty huge. Missouri has some. Ohio has some. Pennsylvania has some. Maryland has some. Virginia has some. Very surprisingly, in West Virginia, we have 78.5 million heads of poultry. And that's all coming from the small poultry producers. And we know West Virginia historically is a mining state. We're good at mining, a little bit of stealing. We don't have a small farmers, but our poultry production is actually ranked about 11 in the United States. So we are a big poultry state, you can say. That's why we want to talk about the poultry microbial safety from the microbiology standpoint. Okay, so this is a picture that tells you the broiler production in the United States. Okay, what do we care about foodborne pathogen? Before we talk about this, we want to have a very simple question to you. Why poultry meat is a risk for foodborne pathogen? This need to go back to talk about a little bit of food chemistry. Okay, I'm going to draw the picture like this. The x-axis is water activity. We know that. The partial vapor pressure above the food divided by partial vapor pressure of pure water. The y-axis, we say equilibrium moisture content. Every food products, they have absorption and desorption curve which looks like this. Or vice versa. Based on this, you could be categorized into 3 different categories. And this is usually 0.25, 0.75. The area here on the left side, this is, we call it is a monolayer. Basically, it's monolayer water. And the middle, we call it additional layer. Additional layer of water, and the last one we call it a free water, and basically it is capillary water. So what are the food products fit the first one? Chips, is that right? It's very dry. What are the food products in the second category? Chewy ball. Chewy chocolate ball in the second category. In the third category, produce, fruits, and poultry meat. And for all these products, what do we really care about? In the first category, what we care about is lipids oxidation. The curve looks like this. That is lipids oxidation. So what happened is, if you have chips, you open, put in the room temperature, it will be maybe turn sweetenish after a couple of days, couple of weeks. That's the lipids oxidation. What do we care about the chewy ball? We want those colors, is that right? Maillard reaction. Maillard reaction, the typical example is the milk powder turns yellow. Now the last one, every these biochemical reactions happen dramatically, but the more important we care about is foodborne pathogen. Because the water activity and the equilibrium moisture content is highly correlated, there's a lot of moisture there. Its available water is higher for bacteria to survive. If you ever cooked a chicken, you know that. You fried it, you boiled it, lots of the moisture comes out. Those moisture bacteria can use and can survive. That's the reason. Okay, this is a very simple example. Why poultry meat is a big risk for the pathogen. In other words, did you ever see There is a news of the outbreaks, 500 tons of chips recalled because of Listeria monocytogenes. You never heard about that. Did you ever heard about E. coli 157H7 in chewy ball? No, you never heard about that because those are not in the category as a big risk for foodborne pathogen. Now, of course, sometimes will happen, but generally speaking, poultry meat is a big risk for the foodborne pathogens. Now, what are they? What are the major foodborne pathogens? This is a list we have talked about all the time. Obviously, these all could be in the poultry meat, but we care about is two. Number one is Salmonella. Number two is Campylobacter. These are the major two harmful pathogens. What are they? Let's talk about Salmonella first, okay? Salmonella, we know, this is gram-negative single lots. It is a it's a facultative pathogen, which means they can grow without oxygen, but grow better with oxygen. But for here, we more care about is another different category for Salmonella based on the temperature. So remember, we have cyclophile, cyclotroph, mesophile, thermophile, and hydrothermophile, hyperthermophile. So what's the range of this temperature? 0 to 20 degrees Celsius. Cyclotroph, 0 to 35 degrees Celsius. Mesophile, 20 to 45 degrees Celsius. Always remember this one. We will talk about that. Salmonella, as a mesophile, can grow up to 45 degrees Celsius. This is a tricky thing when we talk about scottering. Okay. Campylobacter. Campylobacter is a gram-negative, large shape, little bit curved. What's the tricky thing for that one? That is microaerophilic pathogen. What this means, they can only survive the oxygen 2 to 10%, will be died if it's more than 20%. It's very tricky. So, this is something ironic. Campylobacter is a risk for the poultry meats. Because it's a microaerophilic characteristics, it's very difficult to grow in the lab, in the medium. You have a traditional tropic soil broth, nutrient broth, it will not grow. Even you add blood, become a blood agar, it will not grow. It is a fastidious bacteria. And the fastidious bacteria, they can only grow in modified chocolate agar. Now, if you want to do a little bit of review, why they are microaerophilic? Because during the electron transport chain, the bacteria will generate two different toxins, which is hydrogen peroxide. If you have a catalase, this will break down between water and oxygen. If you have a superoxygen, and you have SOD, superoxide dust mutase, superoxide dust mutase, They will break down between these two. This is, we call it a triplet, oxygen is a singlet. And this could be going through is a photo sensor. Okay, we're not going to go detail of the chemistry of these things. Now, for microaerophilic bacteria, they have SOD, but they with limited amount of catalyst. That's why this is a microaerophilic. Since it's a microaerophilic conditions, there are only two things they will grow, either in a jar or chamber. The jar, $400. The chamber, $25K. It's expensive. Okay, so it's very interesting, these two. And we already talked about these. We're going to skip talk about that. Let's talk about something interesting. This is one in 2005, the top 30 serotype of the Salmonella found in the United States. The number one is Salmonella typhimurium, then Salmonella epidermis. Salmonella epidermis, both basically is in the egg products. So you have a Newport, Hindenburg, all these things. Now, by the way, we mentioned about in our first class, Salmonella, it's a little bit tricky. All the Salmonella, what we talk about is Salmonella enterica, subspecies enterica, then you have a name. For example, typhimurium. So what happened? These should be italic and this should be normal. Because typhimurium is a subspecies name, it's not a species name. And most of these Salmonella, we also call it non-typhi. Because typhi Salmonella is a different story. We talk about typhimurium, which is a lady with a very magic miracle in New York City back in 1925. So, these are some background information you should know, since the class is going so far, okay? So, we want to give you some background information as a review. Now, you always keep in mind, when you buy a bird's carcasses, a chicken carcasses from Kuru, usually it's in a loosely attached bag. You see the water is dripping. Does those mean it's zero tolerance for bacteria? No. The United States, the new performance standards of Salmonella and Campylobacter established by FSIS for the Safety Inspection Service in 2015, it allows you to have a certain amount of the Salmonella and the Campylobacter. And Salmonella is up to 7.5% and the Campylobacter is 10.4%. And I will tell you the reason why that's standard. This means it's not zero tolerance. It's different from E. coli 0157H7 in beef products. So keep in mind, Salmonella and the Campylobacter is widely existing on the bird surfaces. Okay, next one. This relates to the microbial safety. The boil processing. If you look at here, the slide shows you the process, which is very standardization in the United States, how they do it. There is a multiple steps. Some of them relate to the food quality, but most of these have a higher impacts of microbial food safety. So we will go detail of these and talk about microbial food safety. First of all, when the birds come here, you're going to hang in there in the comb. You will not them moving, so we call it immobilization. So we do bleeding. The bleeding, we have another terminology for that. We call it exaggeration. Usually they're using an electronic one. You just touch the head, and it will be bleeding You cut off the neck, they will be bleeding like 20 or 30 seconds. When we talk about the beef production, we need to thinking about rigor mortis, tenderization, all these things. And for chicken, we don't worry about that. The reason is the rigor mortis time, that means toughness of the birds. Beef, the curve looks like that. Chicken do not have this age, less than 30 seconds. Okay? So we don't worry about these too much. That's a curve. Then we going through the first process is scattering, which means you dipping or processing in hot water to do defeather. Then we do the pickling, we hand them back, and then we manually or machinery to take out of the intestinal structure, we call it evisceration. And that is actually a major steps for microbial cross-contamination. And then we hand the birds back to do inside-outside the birds wash, IOBW. Then we immerse the birds into the chilling tank, we call it the chilling process, and then we do, sometimes we do vacuum package, sometimes we do aerobic storage, we call it the aging process. The aging process most likely will let the intestinal enzymes to break down the active myosin cross bridge, but that is not very important for the chicken. Okay, processed products, and finally we do the packaging, then we do the label, and we go to the market. And in this class, we want to talk about several things, which is important for the microbial safety. The first thing is pre-scald birds wash. Large industry, what they do, before we do scalding, we do a bird scrub wash. Why? We need to lower fecal load entering into the scalder, which means organic matter has to be decreased. We want to physically to remove the bacteria entering the scalder. And we also want to reduce the mass of the feces into the fossil post-pickling. Now, by all means say, we want to reduce organic matter and the bacteria of the carcasses entering into the chiller. These things are very important. The organic matter is important to control. We'll show you some of the examples, especially related to the antimicrobials using. So first of all, scalding. When you see these pictures, scalding is a very old method. Look at the sentence here. The partridge is scalded with its feathers, and while met with the feathers are taken off the hair skin. You could go back to 1st century AD, they start to do the scalding. So people know how you take out of the feather. You just use hot water. However, there is a lot of the tricky things. First of all, the major point of the cross-contamination of chickens with Salmonella and Campylobacter, as they are liberated from the skin of a contaminated carcass, spread to uncontaminated carcasses. That's a scalding would happen. So scalder, we care about the flow rate. What's the flow rate it is? The directions. We better to do counter current. I'll show you. Is a multi-stage pass or pass scalding. The temperature of scalding is very important. And I'll show you very, very quickly the condition of the water when the birds exist and how many of the birds comes out. And the condition of the birds comes out. Can we still see the visible fecal contamination on the surfaces? That is the key. So this is the important science, the scalding. Okay, first of all, we mentioned Salmonella is a mesophile. So this temperature for Salmonella can grow 20-35 degrees Celsius. Okay, what's a mistake people will have, especially for small producers? They use warm water. Lots of the people using warm water to do scottering, let's say 42 degrees Celsius. What's a mistake? The salmonella could grow because salmonella is a mesophile. They can grow 20 to 45 degrees Celsius. You're using warm water to make yourself very comfortable. However, your cultivation bacteria. Think about in the scottering tank, if you're processing 100, 500, 1,000 birds, what's going to happen? It's a very expensive, time-consuming bacteria incubator. That's the reason why we have a sentence here. Seems like it's a joke, but not really. It's an expensive incubator chamber. If you use a warm water, but lots of people will do. That's the first misconception. Second misconception, the temperature. Some people say, okay, I'm not going to do 42 degrees Celsius. I'm going to dip in the birds into the hot water. I'm going to using more than 70 degrees Celsius because the hot water will kill bacteria. Can we do that? No. What will happen? The bird's skin surface have lipids. Is that right? When you're using hot water, extremely hot water, what happens? The lipids will be liquidization and extracted onto the surface. So, if the birds use surface using hot water, those lipids will come out. Do you know about lipids? You should know about them. That's lipids. Is that right? Stereospecific number 1, triglycerol, then long-chain fatty acids. Triglycerols could come out. All kinds of lipids could go out. So what happened? There is a big organic matter. This is a big organic matter. Especially later on, will accumulate in chilling tank. Then bad thing will happen. I'll show you real quick. So the temperature control is important. Cannot be too low, cannot be too high. What are the temperature control? There is 2 different types of the scottering. Hot scottering, 59 to 64 degrees Celsius, little bit short time, 30, 75 seconds. Soft scottering, 51, 54 degrees Celsius, 90 to 120 seconds. In this process, we don't use antimicrobials very often because it's a very hot temperature. The third thing, every time when you're using the water, should be counter current. C-O-U-N-T, counter current. Which means every time the birds need to facing is a clean water. However, it is difficult to do. I talked to several of the small growers at West Virginia. They said they are using counter current for the scottering. But when you go to see it, it's actually not. Why? Because people design the scotter, they have an engineering mind, but they do not have a food and microbial safety mind. So they think they did a good way, but actually it's not. So keep in mind that this very easy process in the scottering, there are 2 issues, is temperature control and the counter current facing the water. Which means every time the birds have to face the clean water. Okay? They're coming and they're facing the water which is brushed to them. So, we mentioned about the chemical treatments. You cannot using oxidants. Chlorine oxide, hydrogen peroxide, they're going to generate off-gas. And the high organic load immediately blind and deactivate organic chemicals. So, you cannot do it. Because scottering, these hot water will generate off-gas. And also, lots of the dust, debris, fecal samples is on the chicken surfaces. It's a huge organic matter. So chlorine is very easy to be affected by the organic matter on the chicken surface. So that's why we don't do oxidants. We can using some of the strong acids, let's say lactic acid, citric acid, but we barely use it. In the practical area, we barely use that. Okay. Pickers. This is very interesting. What's a concern here? Is feed withdrawal. Okay, feed withdrawal of the birds. You need to make sure around 12 to 16 hours, no more than 24 hours. What will happen? If the feed withdrawal is too long, your intestinal is empty. So going through evisceration process, it's very easy to break down, become soft. When you take out of the intestinal, it is broken down, there will be a major cross-contamination. But in the other direction, you cannot withhold the feeds too short. Okay, you feed the birds already in the morning, then 2 hours later you kill the birds, what's going to happen? The intestinal, ceca area, Ilian, Sicilian, they all feed with different type of the birds. The feeds could be carrying a huge amount of the microbiology, microorganisms. So the feed withdrawal is very important. Okay, next one. So pickers, what we do? The rubber fingers in 3 fingers in pickers, we squeeze coccyx, make feces come out. We rub feces or skin around and cross-contamination from coccyx to coccyx. This process actually can significantly increase salmonella preference and the Campylobacter numbers. CAP is found in high numbers in the ceca, which is expressed during pickering. I have the data number for that. In the ceca, is almost 100% will be harbored with it. So for the pickers. Okay, evisceration. This is the process, usually is a manual evisceration. The major point of the cross-contamination. So, you can see a picture here. This is the birds was not off the feed for sufficient time. You see the feeds there, okay? So major point of cross-contamination of chickens with salmonella if equipment is not adjusted correctly, improper feed withdrawal, or very weak intestinal, which means the feed withdrawal is too long. So what we do? After evisceration, we take out of the intestinal. We're going to hand him back to do inside-outside the bird's wash. This relates to the antimicrobials. You have a nozzle. The nozzle, you need to give them an appropriate amount of the water, the cover the surface, appropriate amount of the speed, and the area. So you see here, on the left side, very good. These works very well. On the right side, they are not working very well. This guy does not work at all. During this process, we actually need to do a couple of things. We need to make sure the pH is around 6.5 or below 6.5. We'll explain to you. The chlorine concentration, we use chlorine all the time. Another one we use in peroxyacetic acids. We'll mention real quick. Chlorine, we do 40 to 50 parts per million. That has to be pre-measured. We need to make sure the pressure is there. We need to make sure the distribution is good. This is a survey did by Dr. Shelley McKee, used to be associate professor at Department of Poultry Science in Auburn University. In 2015, she did a survey of what type of the antimicrobials do you using for the inside outside of bird's wash. Now, by the way, inside outside the bird's wash, because after evisceration, we handing the birds back home, spray with antimicrobials, so we also call it OLR, online reprocessing. So called OLR, which is an acronym. So what are these things find? Number one is peroxyacetic acids. Used to be the number one is chlorine. The reason is, by the time when they do the survey, Russia is a major chicken importing country in the United States. So Russia and some other European countries do not allow to use chlorine. So peroxyacetic acid is the number one in the United States, about like 40%. Chlorine is about 20%. Then strong weak acid, like acetic acid, lactic acid is the third one. Acidified sodium chloride, which is ASC, that used limited less than 10%. CPCE or bromine, we barely use less than 10%. So, I'm going to introduce you several things about here. What are they? Okay? Since we are talking about antimicrobials, we not just go over real quick. We want to introduce to you what are they, what are these things talk about. So first thing, let's talk about the chlorine. I like to talk about the chlorine first. This is a very interesting topic, talk about the chlorine. So chlorine, Cl2. If chlorine dissolves in the water, what will become? HClO and HCl. What are these? Hypochlorous acid. This is hypochlorous acids. This is the key thing. We refer to as free chlorine. Okay, now this guy here, HClO, could go two directions. In relatively low pH, they will become chlorine off gas and water. In relatively high pH, in the alkaline solution, they will become chlorine ions, and also could have part of the thing is water comes out, could be like this. Okay, you always keep in mind, when the chlorine we talk about antimicrobial efficacy is referred to hypochlorous gases, not for the others. This is we call chlorine ion. So chlorine solution, this is off gas. So chlorine solution, very sensitive, number one is for pH. How sensitive it is. Okay, this is the pH. X-axis, Y-axis is chlorine type. We use percentage. What's the curve looks like? This is the curve for hypochlorous gases. Right in the middle is pH 7. 6, 5, 4, 3, 8, 9, 10, 11, 12. Now I have to draw other two curves. What's a curve of chlorine ions? Like this. This is chlorine ions. What's a curve of chlorine off gas? Chlorine off gas. So, here is a tricky thing. During the pandemic, you all go ahead to buy Corax. I believe you have a lot. You have a Corax you dissolve in the water. The pH is 12 or 11. By the time it's all filled up with chlorine ions, do they have antimicrobial characteristics? Yes, a little bit. Because you didn't adjust the pH. So what's the industry they do? They are pumping carbon dioxide, become carboxylic acids. Or in the fresh produce industry, they add citric acids. Because they could lower down the pH in this category, they will be dominant with chlorine, with free chlorine. Now what happened right here is Because chlorine is very easy to be reacted with organic matter, especially free chlorine. So if you have a container, you dump in Chlorox, then the container is not cleaned. You have debris, dust, soils, everything there. It will be decreased the free chlorine concentration from 50 parts per million to 0 in 30 seconds. Now what the small producers they will do is they will re-add the free chlorine. They dump another box, another bucket of hypochlorous gases. So what happened? The pH going to decrease, they generate off gas. This off gas will let you tear. Like crying, but you're not feeling sad, but you cannot open your eyes. Okay? So that is chlorine off gas. So very important is control the temperature, control the pH and the organic matter. Now we could also draw another picture for you. You can understand about that. This curve going to look like this. The x-axis is the pH. So what it looks like, we go 4, 5, 6, 7, 9, 10, 11, this go 10, 20, 30, 50, go 100. This x-axis, we call it CHLO. And this here, we go 0 to 100, go different direction. We have 10, 20, 30, 40, 50, and this is chlorine ions percentage. Now, some people talk about the temperature. Does the temperature matters? Yes, but not really, unless you use hot water. If it's not hot water, this curve is 0 degrees Celsius, 20 degrees Celsius looks like this. Not really, not change too much. Okay, so that's chlorine. We said used to be the number one. Why? Because it's cheaper. $6 for 1 gallon pound. So, but it's not approved to be used in Russia and in EU countries. Why? Because it will generate chlorine byproducts like trihalomethane, haloacetic acids, or those carcinogenic material. They said they will cause blood kidney, and I don't think so. Blood kidney cancer, but I don't think so. Okay. So what comes out with peroxyacetic acids? What is that? Peroxyacetic acid. It is a combination between this guy, acetic acid, and the hydrogen peroxide. Once they reacted, what's the products they will generate? That's simple. Why? It's magic. This kind of like a beta scission of long-chain fatty acids, but it's short. This will comes out, become a hydroxy-free radical. This is a highly energized radical. It will be extracted the free proton from other chemicals, especially fatty acids. So, in a bacterial cell wall, will they have fatty acids? Remember fluid mosaic model? This phospholipids, this here area, very thin, peptidoglycan. Okay, now you have a double layer here, it goes here, top, here, goes here, go here. Here you're going to come out with what? LPS. That's lipopolysaccharides. It has lipids A at the top. So with this highly energized free radical, they could be damaged Do some of destroy here, could destroy here. This will generate endotoxin, by the way. That's why Salmonella E. coli is a big risk. Now, in the industry, the chemical industry, they combine this with that together, generate a new product called Sanidate 5.0. That's the research what I did in recent 5 years with my students, which is a mixture of peroxyacetic acids and hydrogen peroxide. So this is what the peroxyacetic acid is talking about. Okay, next one. What is the strong acid it talks about? This is something else we want to mention. It's kind of also very interesting. I want to draw here. This is acid. Most of these acids are weak acid. Weak acid will dissociate, become, and the proton comes out. So what happened? They come out with a concept called the pKa value. The pKa value is pH at which the concentration of the undissociated equals the dissociated one. Now it's very interesting for these weak acid, only this undissociated one will go through the bacterial cell wall. So what happened is the bacterial cell wall, this is going to go in, then what happened? Have this comes out, have the acid comes out. Bacteria cannot survive in the acid environment. Most of the bacteria survive in the neutral pH. So what they do? This needs pumping out. How are they pumping out? They need ATP. Hydrolyzed become ADP and the phosphates. And this needs ATPase, ATP base. What is ATP? Do you remember? Go here. H, OH, H, OH, CH2. Go here. O, phosphate. O, phosphate. O, P, phosphate, phosphate. This is NH2. This is N. Is that right? Trifolate phosphates. So that's important. So what's the restriction for that? Why people don't use too much? This pKa. They only using when the pH is near or lower than pKa, which means most of the acids, the pH have to use about 5.5, below that. Chicken meat is about like 5.7-ish, pretty much, so they use it. However, they generally don't want to work log reduction. That's the reason. Okay, ACS is sodium chloride, just add acid. Not many people use it. Why they don't use acid, do you know? Because it's corrosive. You have a metal, you add acid, it will decay. You have a hands touch acid, it will be burning, looks like. It's very corrosive, so people don't use that. Now, there is a certain amount of the people in the world, especially in the European countries, they use EO. What is EO? Yes, I have to tell this one out. Well, something said it's very magical. What's EO? EO is electrolyzed water. Electrolyzed water. That's called EO. What is that? It's very interesting. You add it there. Okay, in this big chamber, you will add salt. Of course, this salt is food grade. Then you add water. Add water, sorry. And this is electrolyzing. So what happened? This comes out, this comes out, this comes out, this goes here. There are two locations, positive, negatively charged. This is, we call it anode. Is that cathode? Is that right? Cathode. So what happened? Where are we going to be here? HClO will be here. What going to be here? This guy comes up. Hydrogen peroxide. Oh, sorry, sodium hydroxide. This is free chlorine. What is that? That's cleaning. Cleaner than can clean it. But at the beginning, the electrolyzed water comes out, it's very acid. So we say it's acidified electrolyzed water. People doesn't like it. It's too corrosive. So what they do, they add a membrane system in the middle, they call it switch the pH, then become neutralized. Neutralized. EO. That's pH around 6 to 7. But I want to tell you one thing. Why they do it? Because they couldn't replace free chlorine. I haven't done some of the research showing this kind. The HCl come out from the from the electrolyzed water. Are they going to still generate organic matters? Are they going to still generate trihalomethane? Of course it will. But what's a good thing? You know certain amount, and you can control the time, and you know know the pH, because it will be automatically comes out. That's a good thing for them. Okay, electrolyzed water. So these are the major chemicals they use in the United States. Then we're going to talk about something for the chilling. So when we have a birds to do inside-outside birds wash, sprayed with all these chemicals, we move on to the last step, which is chilling. Chilling is usually the cold ice water, less than 40 degrees Fahrenheit, for about at least 45 minutes to 1 hour, could be 2 hours, or even overnight. It depends. And I want to tell you one thing. Chilling is the most effective way to control pathogen. Chilling can cut salmonella by 50 to 70% because of the contact time. You have enough time for the birds to expose to the antimicrobials. Could be effective to kill them. Same survey Dr. Shelley McKee did. The antimicrobial in the chilling tank, the number 1 is peroxytic acids. Number 2, chlorine, then weak acid. But barely people use it. Okay, here is the thing. We need to control the organic load in the chiller. Number 1, bleed out. Okay, make sure you completely bleed out, because bleeding, the blood is the organic matter. Make sure there's no feces is on the skin surfaces. If you have a poop sample is on the chicken surfaces, of course, it will make the chilling tank look horrible. Make sure the flow rate direction is also countercurrent. Here is the thing, the scalding temperature is important. I just said the scalding temperature is important. If the scalding temperature you're using too high, you use 70 degrees Celsius, what will happen? The liquidization. Look at what happens. All the fatty acids from the skin surfaces is floated in the chilling tank. And 40% of the birds, salmonella positive, go to the chilling tank, come out, become 53% positive. It's horrible looks, because the temperature control during the scalding is failed. So that's important for them. Okay, let's go back to the slides here. Number of the coccyx rinsed. How many coccyx you are doing? How many you are doing the inside of outside the bird's wash? In the chilling tank, we also want to do countercurrent. Look at the birds here. They are doing the chilling really good. That's in the United States. Look at the water, how good it is. Very clean. But I want to tell you one thing, unfortunately. This is done in Chile. This is done in El Salvador. We barely can get any of the clean water in the United States. It's very tricky, very interesting. Okay, these are taken from Central American countries. What the EU will do, European countries, they don't do in-house dipping chilling. They do air chilling. They hang in there and passing through the cold water. Oh, sorry, the cold air. So air chilled, and you get some air chilled in the markets in the United States also. You have organic air chilled. You can get a bag about $10, $12 from Whole Food markets. We say it's organic process. But let's see some of the results. We are very proud to say the percentage of the salmonella positive brown carcasses is the best in the United States compared to EU and Australia. This is the survey has been done about 10 years ago of post-chill carcasses in the United States is about 5% of salmonella. EU is 15%. Australia is more than 35%. Why we did a good job? Because we do a multiple hurdle control. Is that right? We had a scattering control very well. We had an inside outside birds wash. We do an in-house keeping of the chilling. We're using antimicrobials. EU, they have a wild different methods. Some of them they're using air chill, some of them they're using vaccination, and the vaccine is effective for Campylobacter, but not very good for Salmonella. And some of them are good for Salmonella, but not very good for Campylobacter. But I also want to mention for EU, although we get a 15% positive range, it is a wide standard deviation for those countries. So Western Europe, you go Netherlands, Germany, they usually 1 to 2%. You go Poland, Slovak, or those Eastern European countries, you get like 50-70%. So you average them, you get like 15%. Same thing, Campylobacter, United States about 10%. EU more than 70%, Australia 85%. And you could see the number here. 10%-ish for Campylobacter, and you see here 5%-ish for Salmonella. This is well fits what we talk about, the performance standards set up by the United States in 2015. So this performance standards is actually coming from the surveillance survey of those pathogens. Okay, so we're not done yet. Let's just finish it. What we do in West Virginia, we do mobile poultry processing. This is a large unit, $90. Sorry, the small unit, 30K. 90 barrels per hour on farm, 50 to 300 birds per batch. What's the problem? The waste control is difficult. And I can tell you the nearby states of Kentucky want to develop a poultry program, but they can't get rid of because the waste is difficult to control. This is the enclosed MPPU. The Department of Agriculture in Charleston, they have one, $90,000. And the Farmers Market Association, they have one. They can process 120 birds. And 200 birds per batch. It's USDA FSIS inspected. So what are the MPPU processing? This is a picture what I took with Dr. Joe Motz about 10 years ago. We do bleeding, exquisition, we do scattering, and we do defeathering. We directly go to evisceration, and we do chilling. We do chilling overnight, and we're using only 5 ppm chlorine. We didn't use too much. But I will tell you the pathogen certainly existing on the final birds, but not going to reach 7.5 and 10.0%. I have the research just published at the Poultry Science. Kind of very interesting about that. This is a trailer. You could drive to everywhere to the West Virginia to do the service. Okay, so it's very interesting. We talk about the poultry meat safety. from the industry perspective, from the local perspective, how about to control those, especially those antimicrobials. There's a lots of chemicals we talk about. Okay, so this is almost end of the material what we have. When you guys do the presentation, we're trying to jump in the vinegar manufacturing, relate to the fermentation, and also the beer brewing. We're trying to jump in if you have if we have time. Okay.